Okay. So the second example I want to show you is integral of square root of a squared minus x squared dx times 4 integration from 0 to a. Okay, let's try to picture this before we do the integral. What is the graph of y equals the square root of a squared minus x squared? It's a half circle, top half circle. And if you're integrating from 0 to a, what does this integral mean?
You're only doing 1/4 of it?
You're only doing 1/4 of a circle. Right? It's 1/4 of a circle. It's only the right side, so this would be 1/4. And then if you multiply by 4, what would that give you?
The full circle.
It will give you the area of the whole circle, right? And we know that this is a circle of radius a, therefore the value of this integral must be? What's the value of this integral?
X squared.
It's the pi r squared.
Yeah, pi r squared, or pi a squared.
Yeah.
That's the formula for the circle area. The area of the circle is pi a squared. So we actually know the answer. But here we're just using some facts from high school geometry or before. All your life you were told again and again the formula for the area of the circle is pi r squared. And there was some explanation given for it, which is a bit more geometrical, but you probably didn't understand why. You didn't understand the reasoning behind it. So here's our chance to actually verify that this is true by using calculus. So we're going to actually do this integral to verify that the value of this integral is pi a squared. Okay? So let's try that. What do we do? In the chart, which one is it?
X equals
A sine u. That's what we need to do. We set x as a sine u, and then dx would be? You differentiate both sides where a is a constant, so what is it? A cosine of u times du. And then this square root of a squared minus x squared, you really need to compute it by plugging in, but we'll cheat and just use this, okay? But using this table is cheating. You really want to just memorize this part and derive this one on your own, okay? So this is a cosine u, which now will, and in addition, we have to change the bounds as well, right? For definite integrals, when you do u substitution, you have to change the bounds. So when x is 0, what does that mean for u? Well, this is 0. 0 is equal to a sine u. So you need, dividing a both sides will give you sine of u being 0. Sine of what is 0?
90 degrees. So pi
No,
2.
cosine 90 degrees is 0.
Oh.
Sine of?
Sine of 0.
Sine of 0 is 0. So this makes u equals to 0. Now when x is equal to a, that's the other bound. Let's see what that says. That means if I plug in a in here, a must equal to a sine u. Dividing both sides, you get 1 equals to sine of u. Okay, so when does sine become 1?
1.
Sine of?
Sine of 90 degrees.
Sine of 90 degrees is
so
1,
pi
right?
over
So
2.
90 degrees is pi over 2. So we know that u must be pi over 2. Now, sine is a periodic function, so you actually get many different values satisfying these, but as I explained before, you're really limiting your u to be between negative 90 degrees to positive 90 degrees for this inverse function to be defined, okay? So these are the values that will replace the bounds. Therefore, here's the integral. It'll be 4 times 0 to pi over 2. Square root of a squared minus x squared is replaced by a cosine of u. And dx is replaced by a cosine u. du. Therefore, you get 4a squared. A is a constant, so you can bring it outside the square, outside the integral, and you end up with cosine times cosine, which is cosine squared of u du. How do you integrate this? How do you integrate cosine squared? Yeah.
G read.
You use this formula, yes. So this will become 4a squared, 0 to pi over 2.
Take the 1/2 out.
Yeah, take the 1/2 out and you put 1 plus cosine 2 d. Right? So that will be 2a squared. If you integrate 1 by du, it will be u. What's the integral of cosine 2u? Cosine 2u integrates to 1/2 sine 2u, right? This 2 will create a reciprocal 1/2, right? And then you plug in pi over 2 and 0. Okay, when pi over 2 goes into here, you get sine of 2 times pi over 2. 2 and 2 cancels, and you get sine of pi. What's sine of pi? Sine pi is?
1.
Nope.
0.
0.
No, yeah,
Sine
0.
pi is 0. When 0 goes in here, sine of 0 is?
1. Oh,
0.
0. Okay, you have to review your trig values, okay? So in both cases, when you plug in pi over 2 or 0, this will produce 0. And the only time it's going to give you a non-zero value is when this goes into u. Okay? When 0 goes here, it's again 0. The only time you get a non-zero value is pi over 2 going into u, which gives you 2a squared times pi over 2. 2 cancels, and you get pi a squared, which is what we wanted to know. That was exactly what we wanted. Right?